5.2, logarithmic functions and their graphs. So yesterday we talked about exponential. Today we're going to talk about the inverse of exponential, which happens to be logarithmic. We're going to evaluate logarithmic functions base A, graph logarithmic functions. I've already told you they are inverses to exponential. Recognize, evaluate, and graph natural logarithmic functions and word problems. Yay. Every function of the form f of x equals a to the x passes the horizontal line test. A to the x, what kind of a function is that? Exponential, okay? And we talked about exponential functions yesterday, passing the horizontal line test. Because they pass the horizontal line test, that makes them one-to-one. And because they're one-to-one, they what? Have an inverse. Okay. This function is called the logarithmic function with base A. Definition of logarithmic function, base A. Notice x has to be positive. A has to be positive, but it can't be 1. Okay. Y equals log base A of x if and only if x equals a to the y power. F of x equals log base A of x. So that little subscript A is the base. Okay. It might be in here later on, but if I just said log x, do you see a number there? It's not a 1. Because notice A has to be greater than 0, but A can't be 1. Okay. The number that you don't see right there is 10. Okay. Look at your calculator. Look at the log key. What is shared with the log key? 10 to the x. 10 is the base. Okay. So some weird stuff we got going on. If you see this symbol, what number is right there that you don't see? 2. But it's there. We understand that it's there. If I have xy squared, what is the exponent on the x? It's there, but we don't write it, right? So lots of unwritten numbers are actually there in math. I'll do one more and we'll talk about it. So I'll change back to blue. If I had this, what's the base? What's the base? E. This is the same thing as that. So natural log has a base of what? E. Okay. So stuff to know there. So back to logarithmic. F of x equals log base A of x. That is the logarithmic function with base A. Notice the base is A. When you raise something to a power, what do you call that thing that's being raised to the power? What do you call this A if it's being raised to the y power? It's the base. You take the base to a power, right? So y is the power. So if I gave you y equals log base A of x, then that means that x is equal to a to the y power. And we'll do some stuff with this later on. It's kind of new to you, I know. Have you ever done logarithms before? Anybody? That's what I thought. Brand new stuff. So y equals log base A of x and x equals a to the y power are the same thing. The first equation is in logarithmic form and the second equation is in exponential form. For example, 2 equals log, ignore what you see over here. 2 equals log base 3 of 9. What is the relationship between the numbers 2, 3, and 9? 2, 3 squared is 9. 3 is the base, 2 is the exponent, 9 is what I call the thing. I'm taking the log of something. So 3 squared is 9. So we could write that as 9 equals 3 squared. If I gave you 5 cubed, what's the base? 5 cubed, what's the base? 5, which means I would write log base 5. Okay, so 5 cubed equals 125 is the same thing as log base of 125 is 3. 3 is the power. 5 to the third power is 125. When evaluating logarithms, remember that a logarithm is an exponent. This means that log base 3x is the exponent to which must be raised to obtain x. For instance, log base 2 of 8 equals 3 because 2 to the third power is 8. A logarithm is an exponent. This is the exponent, which is 3. 3 is the exponent, right? So log base 2 of 8, which is 3, log base 2 of 8 is an exponent. All right. I missed one. Thank you. Nope, that was the bottom. F of x equals log base 2 of x. X is 32. A is telling us what is log base 2 of 32. That's what it's asking, right? What is the base? 2. What is the power? Question mark. Equals 32. 2 raised to what power is 32? 5. 2 to the 5th power is 32. Part B says log base 3 of x, where x is 1. That means we got log base 3 of 1. What's the base? 3. I don't know the exponent, which is the power. I don't know the exponent, but what's this going to equal to? 1. 3 raised to what power is 1? 0. Anything raised to the 0 power is 1. Do part C. Anybody think they have it? Mm-mm. This one get harder all of a sudden? Part C is asking us calculate log base 4 of 2. What's the base? 4. We're looking for the exponent, right? 4 raised to what power is going to be 2? Why 1/2? What 1/2 means what? An exponent of 1/2 means what? What'd you say? No. What does an exponent of 1/2 mean? It's not half. It is in this case, but that's just a fluke. No. X to the 1/2 is the same thing as the square root, right? Top number is the power, bottom number is the index. You recall me saying that in the past. When you have a rational exponent, the bottom number is the index, okay? So in this case, it is 1/2. D. We have log base 10 of 1/100. What's the base? 10. What are we looking for? We're looking for the exponent, right? 10 to what power is a very small number? Okay. Okay. -2. Remember, negatives are reciprocals, right? So as soon as we put the negative there, 10 to the -1 becomes 1/10. But I don't want 1/10. I need that 10 to be squared. So that's why it's -2. Questions on these? The test is made by the department, not by me. Okay, so there's the work for C and D. I'm going to go ahead and go back up and uncover the work for, clear all this. There you go. Okay, so there's AB and CD. Next page. Logarithmic function with base 10 is called the common log. It's denoted by log base 10 or simply log. So if I just say log, I mean base 10. I'm not going to say it. Log 6 means log base 10 of 6, right? Okay. On most calculators, this function is denoted by log. The following properties follow directly from the definition of logarithmic functions with base A. Log base A of 1 is 0 because A to the 0 power is 1. Log base A of A to what power gives you the A? A to the first power. Okay. Log base A of A to the X is simply X. If log base A of X equals log base A of Y, the only way that happens is if X and Y are the same. Questions on any of those properties? Those properties, and guys, there's a lot of log properties. If you haven't started your cheat sheet already, I would go ahead and start a cheat sheet for the next test and have a little section of the page for log properties. So you know them all in the same spot. Okay. No. There's quite a few. To sketch the graph of y equals log A base X, you can use the fact that the graphs of inverse functions are reflections across line y equals X. Okay, so yesterday we talked about exponential, right? What does an exponential function look like? Okay, it's down here, right? And they all go through this point 0, 1, and then they take off, right? What would that look like if I reflected it across that line? Let me go ahead and name this guy here. This guy was f of x equals exponential. I'm just going to put a to the x power, right? Something raised to the x power. Reflect it. Would it start down here? It would, wouldn't it? So it's down here. Does that look fairly symmetric? Okay. Any idea what this point is? 1, 0, right? If this is 0, 1, then this has to be 0, 1. I mean, 1, 0. Okay. So this right here would be the graph of, I'm going to call it g of x equals log base a of x. Remember on the definition earlier, it said the a has to be greater than 0. You remember that? A is greater than 0. Well, does this graph ever get to 0? No, it gets closer and closer. So a has to be greater than 0. So that's what that's talking about. Questions on these graphs? Okay. Next slide is going to probably show the same thing. Nope, doesn't. In the same coordinate plane, sketch the graph of each function. Let's sketch the graph of 2 to the x and log base 2 of x. Is it fair to say that I just did that? Does that make sense? Let me go back to the previous slide. Can't I say that this blue graph is 2 to the x? Because they all have the same shape, right? It might be flatter and then steeper based on the value of a, but this is the general shape of an exponential. So this could be considered f of x equals 2x, 2 to the x power. And this would be then log base what? 2. Okay. So this graph does satisfy what the next question is asking. So I've already done that. I don't want to spend time doing it again. Okay. Here's what it would look like if you constructed a table and just plotted some points. Plot the points, sketch your graph, reflect those points. So if -2, 1/4 is on the graph of 2 to the x power, if you switch those, you get 1/4, -2. 1/4, -2 is right there. The graph of 2 to the x power, -1 goes to 1/2, -1, 1/2. Switch those, 1/2, -1. Y'all following all that? And then we can just keep going. All we have to do is graph 1, swap the x and y, and there's the inverse. Questions on this? This is what I just said. Because they're inverse functions, swap your x's and your y's, draw your curve. The nature of the graph in figure 511 is typical of functions in the form f of x equals log base a of x, where a is greater than 1. They have one intercept and one vertical asymptote. Notice how the graph slowly rises for x is greater than 1. So between 0 and -1 is rising very quickly. As soon as we pass the point 1, the x value of 1, it begins to rise slowly. Okay. The features of logarithmic function. Domain. Can x be anything? No. I do want to point out something. Yesterday we did exponential. What was the domain of exponential? On exponential, the x can be, what was the domain yesterday? Y equals a to the x. What can x be? Anything, right? So on exponential, the domain was all reals. What's the range of logarithms? Why? Because we swapped the x and the y, right? Isn't domain your x values? So if the domain on exponential is all x values, that means the range is all y values on the logarithm. Okay? Same is true of the domain. The domain of the logarithm is the range of the exponential. The x-intercept is at 1, 0. This function is always increasing. It's 1 to 1, therefore it has an inverse. And we talked about the inverse of this guy yesterday. It's continuous. The y-axis is a vertical asymptote. The reflection about the line y equals x is exponential. More properties there. Moving on. What about e to the x? What's it going to look like? It's going to look the same, folks, right? E is just a number, 2.718. So instead of 2 to the x power, we have e to the x power. Okay. I talked about this earlier. Log base e of x is the same thing as saying natural log of x. So if I say natural log of x, you must understand that the base is e. I was like, what the heck is this? They actually spelled out the word ln. ln of x. Okay, whatever. Natural log function and the natural exponential function are inverse functions of each other. Every logarithmic equation can be written with an equivalent exponential form, and every exponential equation can be written with an equivalent logarithm form because they are inverses of each other. Yes, yeah. Okay, so y equals natural log of x. What's the base? E. What's the power? Y. So e to the y is x. Here's the graphs of them. They are inverses. They do reflect across the line y equals x. The ln button is natural log. Okay. What's the natural log of 2? What are you going to type? Make sure you do natural log, not log. So you got to do the second, right? Second. So this means what is natural log of 2? Natural log of 0.3. Calculator. Natural log button. It's the same button. The one that says natural log. Yep. There you go. Yeah, it's what you already had. What is the natural log of -1? What? Undefined. Remember what the graph looked like of the natural logs? It was here, wasn't it? It doesn't, x can't be negative, can it? Okay. And natural log of 1 plus the square root of 2. Okay. When you push the natural log, it automatically opens parentheses for you. Okay. Okay. 0.9. It is best if you were to actually close the parentheses, but since there's nothing else on that problem, if you don't, it's okay. So we want a bunch of those on the test too, right? So the display gave you an error on that one. That's because it's undefined. X has to be greater than 0. Make sure when you're doing your homework, you don't enter the answers like we were doing, right? We typed 0.9, but your homework says rounded to 3 decimal places, right, Matt?
Yeah.
Okay.
It doesn't do it on all of them.
The homework I found is very inconsistent.
Yeah.
Yep. Yeah, you have to read the directions.
That's not good at that. I'm not good at reading.
4 properties of logarithms valid for natural logs. These properties are the same. Okay. If you think about it, when you wrote them down a while ago, we wrote down, like this first one, we wrote down log base A of 1 was 0, correct? Yes, no?
Yes.
Okay. This is the same thing as saying log base E of 1 is 0, but instead of writing log base E, we write natural log. Okay, so a natural log, folks, is a logarithm. They're the same. It just has a specific base. Okay. Human memory model. Some of you might flatline on this one. No? Students participating in a psychology experiment attended several lectures on a subject and took an exam. Every month for a year after the exam, the students took retests to see how much of the material they remembered. The average scores for the group are given by the human memory model. F of t is equal to 75 minus 6 natural log of t plus 1, where t is between 0 and 12. T is in months. Are y'all good with that? Can t be 0? Why?
Because it's the day they speak because there's an equals on there.
Okay. Can you take the natural log of 0? Type in your calculator. What's natural log of 0? Okay, because you can't take the natural log of 0, can you? Now back to this question. How come t can be 0? Because it tells us here less t 0 is less than or equal to t, meaning t can be 0. Yeah, we're not taking. Smallest value that this is going to be 1, right? Because when you plug in a 0, you get 1. Okay. What is the average score on the original exam? Write this down. Okay. Original exam. What'd you get? Why? Okay. It's 75 minus 6. What is the natural log of 1? Natural log of 1 is 0. Isn't it? Yes? No? Okay. So it's 75 minus 0. Because 6 times 0 is still 0, right? So what is the average score on the original exam? Better be 75. Who's confused? Okay. Here's what we're doing. We're crashing everything. Calculator open over there. Oh, I didn't push the calculator button. That's the calculator button. $75 minus natural log of x minus a plus 1, right? Second, insert 6. We'll get there in a minute. There we go. Yes? Okay. So if I go to my table, and I've already got mine set to ask, if I enter 0, I get 75. What is the average score at the end of 2 months? So 2 months have passed. You take the test again. You haven't applied the knowledge you had when you took the test originally. So you're going to lose the knowledge, right? Okay. So when you plug in 2, what do you get? Okay. 68.4. Molly, you good? Okay. What is the average score at the end of 6 months? $63.3. Notice that it started dropping fast, but then it slowed down, right? That's what natural log does. Go ahead. You typed log instead of natural log. 75 minus 6 natural log of what? What's t? Zero plus 1. Any other questions? Okay. There's part A, 75. Part B, 68.41. Part C, 63.32. And that's it for 5.2. Any questions?